For a paired differences on salt, we're going to look at problem 1 from your next to last homework link. Is fishing better from a boat or from the shore? Pyramid Lake is located on the Paiute, I guess that's how you pronounce it, Indian Reservation in Nevada. Presidents, movie stars, and people who just want to catch fish go to Pyramid Lake for a really large cutthroat trout. Let capital B represent hours per fish caught fishing from the shore, and let row A represent hours per fish caught using a boat. The following data are paired by month from October through April. We're going to use a 1% level of significance to test if there's a difference in the population mean hours per fish caught using a boat compared with fishing from the shore. And we're going to define that difference as B minus A. So shore minus boat, whatever the difference is, that's going to be D. Our level of significance is 1%, in decimal form that's 0.01. Now, as far as the analysis goes, when you press salt and the next screen opens up, your data will be pre-populated in here, shore, boat, and what we're going to do is in this navy box, we're going to select inferential statistics. Under settings, we're going to change this to paired T, and we're going to leave the order the same. Salt knows the order it's supposed to calculate. Variable 1 is the number of fish caught per hour from the shore. Variable 2 is the number of fish caught from the boat per hour. We're going to leave those where they are. Our standard deviations from each sample are pretty close to identical. We'll kind of keep that in mind. Now I'm going to go back and start answering some of these questions. All right. So we're going to assume there's no difference in fish caught from the shore or the boat. And because the problem says to test if there's a difference and didn't specify whether one method was better than the other, we're going to have a two-tailed alternative hypothesis where we're going to just say that the mean difference in fish caught per hour is not 0. Sampling distribution down here, we're going to use the student's T, and we're going to assume that the difference between the two categories is approximately normal. And yep, for the rest of this, we're going to need to do some analysis on salt. So let me scroll here. We're going to be asked about sample statistic, that's our T value, and then our P value. That'll help us determine whether to reject or not reject the null hypothesis. So let me go back to salt. Hypothesized difference is 0, and that just means there's no difference in the number of fish caught per hour, either onshore or from a boat. And we're going to say not equal to 0. When we click generate results, over here, our T-score is 2.024, and our p-value is 0.0893, 894 if you wanted to be real precise. Let's go back to our problem. Our t-statistic, remember that we're going to pick this value. We got to be careful of our rounding. Rounded to 3 decimal places, that's 2.024. Now for our p-value, it was 0.08 and some change. That's between 0.05 and 0.1. So we'll make a selection here for our p-value. Since p is larger than alpha, because we set alpha at 0.01, and we're doing a two-tailed test, this is our correct bell curve, and the shading is two-tailed. What we're going to claim for parts D and E is at the alpha equals 0.01 level, we fail to reject the null hypothesis, and that's because P is larger than alpha. We're going to conclude the data are not statistically significant. Remember, those go hand in hand. Part E states your conclusion in context of the application. We are failing to reject the null hypothesis, so there's insufficient data to claim a difference in population mean hours per fish between boat fishing and shore fishing. Number 2. At 5 weather stations on Trail Ridge Road in Rocky Mountain National Park, the peak wind gust in miles per hour for January and April are recorded below. Does this information indicate that the peak wind gusts are higher in January than in April? We're going to use alpha equals 0.01, and we're going to let our paired difference be defined as January minus April. The significance level, remember that's alpha, that's 1% in decimal form. Now, this one we've got a comparison word of higher. Does this information indicate that the peak wind gusts are higher in January than in April? So that means if January is a higher amount than April, when we subtract, we should always get a positive value. Higher minus lower will give us positive. Our null hypothesis is just to assume there's no difference in the peak wind gust. But alternatively, we're going to argue that January has higher peak wind gusts than April. And that makes us have a right-tailed test. Let's go to salt, and this will pull in our data. Really, the only difference between this one and the last problem is after we go to inferential statistics, we're going to go back to a paired T. We have raw data, January minus April, so this is listed correctly, January and April. We're going to have 1 minus 2 when it calculates. Down here, we still want our hypothesized difference to be 0, showing that there's no difference statistically between peak wind gust. But we're going to make an argument that January was a higher wind gust than April, meaning that if that's true, that needs to be a positive number. When we generate results, our T statistic is 1.153. Let me go back to our problem. 1.153, that is our sample test statistic. Our p-value, let me go back to salt. Our p-value is 0.1565. Technically, it'd be 0.1566 because that second 6 is enough to round up. 0.1566. Let's go back and see if we can't find that range. 0.1566 will be in this range. It's between those two numbers. Since we're stacking all of our probability on the right end, this is going to be our graph for the alternative hypothesis and where we're looking to test for significance or not. Our p-value is larger than our alpha, so that tells us do not reject the null hypothesis. At the 0.01 level, we fail to reject the null hypothesis and conclude the data are not statistically significant. Part E, Since we failed to reject the null hypothesis, there's insufficient evidence to claim average peak wind gusts are higher in January. Doesn't mean it isn't, we just don't have the evidence to make that claim. And as I scroll back through, everything seems to be good to go. Back up to problem one, the fishing offshore versus the boat. Just remember this one, the alternative hypothesis was not equal to. It's a two-tailed test, so you'll have to be careful when you're in salt. Down here at the bottom, you'll pick not equal for two-tailed, greater than if you see a descriptive like more or higher, less than if you see a descriptor like less or less than. I hope this helps, and let me know if you need anything. I try to be very available by email. Thank you.